Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus, particularly on the application of the derivative of function as slope of tangent to the curve. And the other interpretation is that it is the rate at which the function changes with respect to another. So allow me to present the solution in this manner so that I can discuss 6 problems in just a short while. So here we go. By the way, this is calculator aided, and these problems are taken from the book by Love and Rainville. Find the points on the curve where the tangent is parallel to OX or the x-axis. So if the tangent is parallel to the x-axis, then the derivative of y with respect to x, or dy dx or y prime, is 0 because the tangent is horizontal. So for the first one, so dy dx, derivative of, we just apply power formula. So 4x cubed minus 8x minus 16 equals 0. Although this is calculator aided, you can find the roots immediately using your calculator. The other way is we divide everything by 4. So it becomes x cubed minus 2x minus 4 equals 0. And using your calculator or by synthetic division, you'll find that x is 2 and there is only one real root. So x is 2, and when x is 2, y is, substitute into the original equation, 2 to the fourth minus 4 times 2 squared minus 16 times 2 plus 24, and that is negative 8. Therefore, the point on the curve, this curve here, where the tangent is parallel to the x-axis, is at 2 comma negative 8. We proceed to the second one. So dy dx is 4x cubed minus 12x squared plus 16x plus 32. Then we equate it to 0. This is calculator aided. Your calculator is capable of finding the roots of cubic or even quartic equations. So reducing further by dividing everything by 4, so we have x cubed minus 3x squared plus 4x plus 8 equals 0. And using your calculator, x is equal to negative 1. So there's only one root, and it is x is negative 1. To solve for the corresponding value of y, we substitute into the original equation. Y is quantity negative 1 to the fourth, which is 1, minus 4 times negative 1 cubed, which is, this is positive 4. So 5 plus 8 times negative 1 square, so 13. Then minus 32, negative 19, plus 10. So that would be negative 9. So therefore, the point on the curve y equals x to the fourth minus 4x cubed plus 8x squared plus 32x plus 10, where the tangent is parallel to the x-axis, is negative 1 comma negative 9. We proceed to number 3. This is fraction. So the derivative is denominator. So x squared minus 2x plus 5 times the derivative of x minus 1 with respect to x is 1 minus numerator, which is x minus 1, times the derivative of the denominator, which is 2x minus 2, then all over denominator square equals 0. So don't mind the denominator square because after cross multiplication, it still results to 0. So x squared minus 2x plus 5 minus quantity 2x squared, then we have negative 2x and negative 2x, so negative 4x, then negative 1 times negative 2 is positive 2 equals 0. So simplifying, we have negative 2x squared plus x squared negative x squared. This is positive 4x minus 2x, so positive 2x, then 5 minus 2, positive 3 equals 0, which after multiplying everything by negative 1, it becomes x squared minus 2x minus 3 equals 0, which can be factored into x plus 1 and x minus 3 equals 0. So which checks. So therefore, equating x plus 1 equals 0, so x is negative 1, x1 is negative 1, and y1 is into the original equation here. So negative 1 minus 1 over negative 1 quantity square minus 2 times negative 1 plus 5. So the numerator is negative 2, the denominator is 1 plus 2, 3 plus 5, 8. Negative 2 over 8 is negative 1/4. So 1 point on the curve where the tangent is horizontal is at negative 1 comma negative 1/4. For the second part, x2, x minus 3 equals 0, so x2 is 3, then y sub 2 is 3 minus 1 all over 3 squared minus 2 times 3 plus 5, so the numerator is 2, the denominator is 3 squared, 9, minus 2 times 3, 9 minus 6 is 3 plus 5, 8, 2 over 8 is positive 1/4. So therefore, the second point is 3 comma 1/4. Then we proceed to number 4. Before we differentiate number 4, we expand the denominator. This is quadratic. X squared, 4x plus x, 5x, then 1 times 4, 4. So therefore, that is equivalent to y equals x plus 3 over x squared plus 5x plus 4. Differentiating, this is denominator. Copy the denominator times derivative of numerator, which is 1, minus numerator x plus 3, quantity x plus 3 times the derivative of the denominator, 2x plus 5, then all over square of the denominator, x quantity x squared plus 5x plus 4 squared equate to 0. So that still doesn't matter. Then simplifying the numerator, x squared plus 5x plus 4, then minus, we have 2x squared, then 5x plus 6x is 11x, negative of 11x, so negative 11x, then 3 times 5, 15, negative of 15 equals 0. So simplifying, we have transposing this to the right, so we have x squared, then 11x minus 5x, 6x, then 15 minus 4, 11 equals 0. So there is no real root because the discriminant, b squared minus 4ac, so 6 squared, 36, minus 4 times 11, so minus 4 times 1 times 11, 36 minus 44 is negative 8. Because the discriminant is negative, so there is no real root. Therefore, there's no point on this curve where the tangent is parallel to OX. So that's it for that part. For the second batch of problems, so we have the force between two magnetic poles at a distance r apart is given by F equals K over R square, constant over R square. find the rate at which f changes with respect to r when r is 3. So I'll present two solutions to this case. One is the general form of the derivative of constant over variable, which is negative of constant over variable square times derivative of that variable with respect to the to that variable. Then let's focus on A first. So this is the guide. Derivative of k over u is negative k over u squared du dr. So where u is r squared in this case. So f is k over r squared. Imagine that r squared is u. So df dr is negative k over u. So quantity r squared square. Then the derivative of r squared with respect to r is 2r. Simplifying, this is negative 2k over r cubed. So negative 2k over r cubed. Substituting r, which is equal to 3, then negative 2k over 3 cubed is, so we have df dr is equal to negative 2k over 27. So that's the rate at which f changes with respect to r. The other solution, which is simpler, is we transform f equals k over r squared into the form k r to the negative 2, then apply power formula. So df, derivative of f with respect to r is k times negative 2 or negative 2k r to the negative 2 minus 1, so r to the negative 3, which is more direct. So we have negative 2k over r cubed, which is the same as this. So therefore, when r is 3, we have the same results. So df dr is negative 2k over 27. Then for part B, find the rate at which the radius r of a sphere increases as the volume V increases. So volume of sphere is 4/3 pi r cubed. If we solve r in terms of the volume, so solving for r in terms of the volume, so r is cube root of 3v over 4 pi. Then separating the constant, so we have from the variable, so cube root of 3 over 4 pi, then we have v to the 1/3 or cube root of v or v to the 1/3. So dr dv, so copy the constant, cube root of 3 over 4 pi, derivative of v to the 1/3 with respect to v is equal to 1/3 v to the 1/3 minus 1 is negative 2/3. Of course, derivative of v is with respect to v is 1. So since the numerator is 3 to the 1/3, then denominator 3. So we have 1 over 3 to the 2/3 here. Then this constant reduces to 1 over 4 pi quantity raised to 1/3. So simplifying, we have 1 over 4 pi raised to 1/3, then 1 over 3 to the 2/3 as explained there. And making the power of v positive, so we have v to the 2/3. So dr dv is equal to, we then put 4 pi in the numerator, so 4 pi raised to negative 1/3 but from algebra. Then we have 1 over, we combine this into 3v raised to 2/3. Finally, bringing everything in the numerator, so we have 4 pi to the negative 1/3, dr dv is quantity 4 pi to the negative 1/3, and quantity 3v to the negative 2/3. So that's it. That's the rate at which r of a sphere increases as the volume V increases.